In its infancy, Earth was a primeval hell. A lifeless planet bombarded by massive asteroids and comets. The moon, much closer to Earth, loomed large in the sky. Instead of water, red-hot lava streamed across the surface of our planet. Volcanoes spewed noxious gases into the primitive atmosphere. Scorched and battered, Earth was a planet under siege. Yet somehow, the world we call home emerged from these violent origins. So how did Earth make such an astonishing transformation? How did it change from a raging inferno like this to a place we all know and love? With firm ground beneath our feet, air we can breathe, and water covering nearly 3/4 of its surface. A place where life could take hold and evolve into complex organisms like you and me. Well, it turns out Earth became a habitable planet only after a series of devastating disasters in its early years. And to see how this happened, let's imagine all of Earth's 4.5 billion year history condensed into a single day. Just 24 hours on an ordinary clock, or watch, like this. If we start right now, then the first humans walked the Earth only 30 seconds ago. Dinosaurs began roaming the planet just before 11 p.m. The first multicelled animals evolved at 9:05. Before that, mostly single-celled organisms existed, and we think the first of those appeared around 4 o'clock in the morning. Earth was born at midnight on this 24-hour clock, 4.5 billion years ago. But its violent history began well before that, when huge ancient stars that had reached the ends of their lives exploded. These supernovas cooked up all the chemical elements we know today, including iron, carbon, gold, and even radioactive elements like uranium. Over time, gravity took hold, and this cloud of stardust collapsed into an enormous rotating disk, the solar nebula. In the center of this disk, temperature and pressure rose, and a star, our sun, was born. Eventually, gases like hydrogen and helium would be swept to the far reaches of the disk. But closer to the sun were dust grains made of the heavier elements.
They're circling around the early sun and little racetracks, and occasionally grains traveling nearby will collide. Something like this happens in your house. If you look under your bed, you find that little bits of dust are clutching together into big, large dust balls. And something like that must be what happened in the solar system too. If they collide slowly, it can add up to a larger object and gradually grow.
With enough collisions, dust grew into pebbles, and pebbles grew into rocks. And as the rocks grew larger, so did the collisions.
If they collide head-on or at higher velocities, then they'll actually break apart, like shooting a gun at a wall.
But other times, the rocks stuck together. And the larger they got, the stronger their gravity became.
Because of the gravitational attraction between these bodies, you coalesce. Instead of just making a mess, and you do make a mess as well, You build bigger things because gravity holds things together.
In time, gravity shaped them into small round planets, or planetesimals, just a few miles across.
Gradually they grow from golf ball size to rugby ball size, and then house size and township size. And then one or two of these objects would get large faster than anything else and will become the big boys on the block.
Eventually, some of these planetesimals grew as big as our moon. And then they combined to form the 4 small rocky planets closest to the Sun: Mercury, Venus, Mars, and Earth. But the early Earth bore little resemblance to the planet we're all familiar with. And today, working out exactly what Earth was like as a newborn planet is no easy task. It's sort of like looking at me as an adult and trying to figure out exactly what I was like as a baby. When was I born? How much did I weigh? Now, a snapshot will give you a pretty good idea of what I looked like when I was young. But the Earth was born 4.5 billion years ago, and hardly anything survives from that time to tell us about our planet's infancy. That's because at midnight on the clock, the newborn planet was nothing but a fiery ball of rock covered with lava.
As you go back to these very earliest times, the first few 100 million years, the Earth was so energetic and was recycling material so vigorously and melting material that rocks from that period have not survived.
So to reconstruct the story of Earth's infancy, we look for clues, not from the ground, but from outer space. More than 100 million miles from Earth, between Mars and Jupiter, lies a region called the asteroid belt. Here, trillions of asteroids, enormous rocks left over from planet building, are held in orbit. Every now and then, a fragment of one of these asteroids is knocked out of orbit and set on a collision course with Earth. Called meteors, they can have a big impact.
This exclusive report is about an object from space buried in ice described as a scientific motherlode. We take you first to the northwest corner of British Columbia, near the Alaska border.
Here, a massive meteor plunged through the atmosphere, leaving a streak across the sky. A local bush pilot discovered the debris scattered across this lake, which was frozen over at the time. Realizing the importance of the find, he mailed a few fragments to NASA meteorite expert Michael Zelensky.
He sent samples down, frozen in a case. So I had a real problem getting through the U.S. Customs because they wanted to open and thaw these out, and they were concerned that they were containing deadly pathogens from Canada or something.
Zelensky immediately recognized it as a carbonaceous chondrite, a carbon-rich meteorite formed from the very same stardust that built the Earth.
The last time we had a major fall of a carbonaceous chondrite was 30 years ago. So that means that it's about one time in a career you had this happening to you, and to have it happen to me in my career while I was still young enough to take advantage of it was a very exciting thing for me.
A team of scientists scrambled to collect as much of the meteorite as possible. This was the opportunity of a lifetime. More than 400 fragments strewn across the frozen lake could each contain clues to the very beginning of Earth. Scientists hoped that inside, the fragments would be uncontaminated, in the same pristine condition as when they formed 4.5 billion years ago. If it lives up to expectations, this meteorite could reveal the exact chemistry of the dust grains that built the newborn Earth.
Meteorites are a window on the past, and they tell us something about the conditions in which the solid planets formed.
This particular meteorite is really special. In the first place, it has the highest carbon content of any meteorite, and the highest amount of these preserved interstellar stardust grains of any meteorite, and has a very high water content as well.
In addition, about 90 other elements have been identified. And already, they're providing a chemical fingerprint of early Earth. And within this meteorite are radioactive elements that decay at a precisely known rate, allowing scientists to calculate the meteorite's age. And since most meteorites formed at the same time as the planets, and from the same material, the age of the meteorite gives you the age of Earth and its neighbors.
If you date meteorites, what you find is that almost all meteorites have the same age, about 4.55 billion years old. They're all the same age. It's pretty monotonous. Within a couple of tens of millions of years to hundreds of millions of years, they all have exactly the same age. And so what we do is take the oldest of these ages and use that as the initial age of the solar system.
That narrow range of ages indicates that all meteorites and planets coalesced extremely quickly in the early days of the solar system. But Earth had barely taken shape before the first of several major disasters struck the young planet. Earth's gravity was pulling in huge quantities of debris from space. A continual bombardment that generated enormous amounts of heat on the surface. At the same time, radioactive elements trapped deep within the Earth were decaying, producing even more heat and roasting the planet from the inside. The combined effect was catastrophic. By 8 minutes after midnight on our 24-hour clock, the planet had become a raging furnace. And when the temperature reached thousands of degrees, dense metals such as iron and nickel in Earth's rocky surface melted.
The outer part of the Earth would have been completely molten. We call that a magma ocean. It's a liquid rock ocean, hundreds of kilometers thick.
Do you think the Earth at some point was a big droplet of melt just floating in space? When you have a totally molten object like this, the heaviest elements, and that includes things like iron, would sink to the center of this droplet, and the lightest elements, things rich in carbon and water, for instance, or light elements, would float to the top and float there like algae on a lake.
The global migration of the elements, known as the Iron Catastrophe, would have a profound effect on the future of our planet.